Last session today. Thanks. I'm Charlie Hebson, an engineer in the Maine DOT Environmental Office. This is a topic near and dear to my heart, aquatic organism passage and associated work. It's definitely the best session of the whole meeting, so you're in the right place. Now, before we start, in 2008, we held the conference in Portland, Maine, and we had a full day dedicated to AOP. I'm not sure we called it that back then. And for some reason, I ended up with a box. This is the way we did things back then. A box of CDs with all the presentations. Lots of leftovers. So I brought them to this meeting. So if you're interested to where we've come since 2008, grab one of those CDs. They're out at the registration desk, and I think you'll see a few changes in practice over the years. We have 4 talks this afternoon about monitoring protocols for how we're doing with AOP when we build a structure. We spend a lot of money on these things, and especially we'll be spending a lot more, as you heard from Joe. And so it'd be nice to know how effective we are, if they're holding up, if they're actually delivering fish passage. One of the nightmares is all these stream beds we build in them blow out and disappear. So that's work sponsored by Federal Highway, Western Federal Lands. Our second talk is about bed form evolution. Again, Federal Highway sponsored work. Jen Moore will be talking about that. And certainly in a lot of the projects we do in Maine, we're rebuilding stream beds inside of box culverts, and we're building bed forms, engineered bed forms, pseudo-natural. And we always wonder, how are they going to do? How do they hold up? How do they form? Third talk from Maryland DOT. It's about these drainage projects, drainage improvements, where they're also trying to build in some habitat improvements and restoration work. And again, it's the same kind of work, these nature-like methods, trying to recreate some habitat and passage. And then finally, reports from Northwest Hydraulic Consultants about a big modeling study of large woody debris. And I can remember years ago, I'd hear about it, never thought of it as an engineering tool, and I think we're getting to the point where it's another tool in the toolbox. So it's a great session coming up. First talk is about the update on the monitoring protocol for assessing aquatic organism passage at water crossings by Justin Lennon and Casey Kramer. And this is work being done for Western Federal Lands. Justin is a vice president and technical fellow with WSP USA's Water National Business Line. He specializes in river engineering, complex hydraulics, AOP, stream and ecosystem restoration. He's been supporting the Western Federal Lands on AOP for the past 4 years. Casey Kramer has over 20 years experience in both public and private sectors in hydrology, hydraulics, river engineering, and fish passage. He's been involved with over 400 water and transportation projects. He's formerly the state hydraulic engineer for WSDOT, and he was also a member of TCHH, so he's seen things from both sides. I think like a lot of us, we end up doing AOP, but we didn't start out that way, that's for sure. So it's been a great trip through this field of work. So without further ado, Justin.
Thanks, Charlie. So our presentation today is an update on work that Casey and I presented at the 2020 NHEC conference, for those of you that made the online conference back then. It's a continuation of work that we've been doing for Western Federal for the past 4 years now, looking at the success of the AOP culverts we've been putting out there. So I want to start off first by recognizing the project team with the great leadership that we've gotten from Western Federal with Steve, Sven, Jim, and Jen. They've all been critical to the success of this project and guiding things along, working with Casey and I, and we've had a lot of other collaborators along the way as well. We have an external technical committee that has greatly aided in this program as we've pushed forward, both helping us understand what is important to them about AOP crossings, what's unique about their states and their sites, so that we can appropriately incorporate that into the project, including Charlie. I don't know if we have any other committee members in the audience today, but definitely recognizing Charlie for being here with us today. And then our collaborators that help us find the sites out in the field and have come out with us and tested our field protocol as we've moved through this process and looked at these different culverts. We've had a lot of great collaboration across the country with different DOTs, looking at their sites and documenting best practices and what's working well. So what is Aquatic Organism Passage and why are we doing this? You know, these are essentially fish passage programs, right? You know, if you go back to Charlie's 2008 CDs, they're probably calling them fish passage, maybe not AOP. But as we sit today, nationwide, we're spending billions of dollars building AOP culverts, and there's a lot of different approaches that are out there on how you can go about designing an AOP culvert. Depending on where you're sitting, what state you're sitting in, you're going to have different drivers that dictate how you go about designing a culvert, and we're not seeing a ton of consistency amongst those approaches. So Western Federal and the project team got interested in this and looking at these different varied approaches and starting to document best practices, what's being effective, how are we best spending our money when we get into these AOP programs, or projects, I should say. So the purpose of what we're doing within this project is we're developing a standardized methodology. We worked on that with our technical committee, came across a fairly final version around 2019, I want to say. Our 2020 NHEC presentation was really on that methodology, laying that out. This is how we want to look at things, and then we've been taking that out in the field since then. We're desiring to put together a robust monitoring data set that really looks at this effectiveness nationwide. So we want this data to be taken by future researchers or future teams and really look at this from a data-driven approach to determine what is driving fish passage effectiveness through these culverts and what's driving, stability and success at these AOP installs. The structure itself, so the protocol is built right now as a two-stage structure. So we've got stage one is our as-built data processing, where we really take as a desktop, it's intended as a desktop exercise to go through your as-builts, document what the AOP looks like, what was the bed structure supposed to look like, what was put in terms of structure, and then going out with your stage two and validating that. Stage two right now is a geomorphic driven focus where we're looking at the morphology of the channel downstream, internal to the AOP, and upstream, and looking at some standardized monitoring points or data sets that we can collect and compare over time to both look at how things are performing right now as well as how things are going to be evolving over time if you're doing repeat visits to these AOP sites. So the procedure is put together as a comparative assessment. I mentioned the whole downstream, interior, upstream. Working with our technical committee, we've come into this idea that we really want to look at how these AOP crossings are reflecting nature, how they are reflecting the conditions in those channels that the aquatic organisms, the fish that are living that channel, are naturally adapted to. It makes sense that when you're building your AOP, that you would want it to most appropriately reflect what is natural to that system. It's what the organisms are going to be used to, what they're going to be most apt to pass through. So up to this point, this is where we stand on field application of the process and data collection. We've been out to Washington a couple of times. WashDOT's got a very robust AOP program, so there's a lot of sites to take a look at out there. We've been to Oregon, California, Alaska, Minnesota, Wisconsin, Georgia, most recently to North Carolina and Vermont and Maine over the past 4 years. And at this point, we have about 100 sites in our database looking at the conditions. So the process itself, We have it compiled. It takes about 2 to 3 trained staff to go out and do this. We intend for it to be a multidisciplinary exercise. Sven in particular likes to emphasize the importance of having our fish biologists, our environmental scientists that really have that eye for the sites and what are the organisms going to be most interested in at the site, but also getting our geomorphologists out there, our hydraulic engineers, as we move forward. Right now, we find that the procedure, maybe the first time that someone will deploy the procedure, it'll take 3 to 4 hours to go through an individual site. But once they get used to the procedure and are getting better and more streamlined at it, we're finding that that time drops to 1 to 2 hours, depending on the complexity and what you want to log at the site. We've put the data collection together so that it doesn't require very complex tools when you go out there. You don't need to go out with a total station. You don't really need to go out with a laser level, though Jim has come up with a new procedure using a laser level, so we'll have to modify our talking points there as we go. But largely, we're out there with tape measures, field tapes. Sometimes a survey rod can be helpful just because it's rigid and easy to take measurements when the water's moving in. But we're trying to keep it fairly simple. So sites that we've tested this procedure on already, we intend it to be applicable to everything, but we've gone out and we've tried it against Forest Service stream simulation sites. We've been to HEC 26 sites, some high gradient HEC 26 sites. We've been to low gradient sites. We've been out to see Washington Department of Fish and Wildlife sites. We've taken it and tested it against retrofits, and then various other local design methodologies. So the procedure, it's designed for AOP fish passage culverts of any type, but it's not exclusive to any particular type. We want to test them all. We want to have the widest possible variety of sites documented in this process. So the new development, the updates, start to get into the mobile application that we've put together. So when you came in today, there was a postcard put in your hand about a training opportunity we have coming up that is focused on the mobile application. So we developed it within Esri's Survey 123. You've maybe heard about that one in other presentations at this conference, or maybe you've used it yourself. So this is it's an Esri proprietary software that we have embedded the procedure in right now. It's nice because it's a pretty low overhead option for Federal Highway to roll out these types of mobile procedures. We're really reliant on the backbone that Esri has put in place with their mobile application rather than developing it from scratch. So the tool itself, it allows for offline data collection, which if you guys have ever been to visit a fish passage culvert, you know that that's probably pretty important because most of these ones we get out to, there is no cell service. We're just staring at no bars as we're out at these fish passage culverts, but we can do offline data collection, and then there's an automated download and update to the cloud-based database where this is all going as we collect the data. As far as viewing the data, we have all the standard Esri viewer options. So again, this is a benefit of working within the Esri data platform that we can utilize their other programs. You could even go so far as to download the database and be looking at shape files within ArcGIS. We've got automated report development tools that we've been working on with the process. So if you've got a particular site that's been surveyed and cataloged, including taking all the photos and everything, you can just do an automated download report of that site. It'll return all the information, return all the photos in a nice packaged report for whatever purpose you're driving it for. And given, again, working with the Esri database, we've got cross-platform compatibility, whether you want to go out there with an iPhone, an iPad, Android, what have you. Anything that's going to work with an Esri product is going to work with our mobile application. So the form itself, this is a screenshot of what it looks like as we get in. One of the early lessons learned from our form is this color coding you see on here. One of the early findings was that it's pretty easy to get lost in these complex forms, particularly if you're looking at it on a phone because you're just seeing that limited area of the screen. It's kind of a simple thing to color code, but we've actually found that it's a very effective thing when you're going through these different forms to have this color coding to guide you through it. Other updates include, if you saw the 2020 presentation, we talked a lot about limiting features and that being a driving factor that we were looking to catalog with this. We even had a term at that point we were calling the most limiting feature, where we would ask the people that were out there cataloging for both that downstream reach, the interior, and the upstream, to catalog the one feature they felt was most limiting to fish passage, and that would, the idea being, well, we'll drive our comparative assessment based on that most limiting feature data set. Well, we've had some heartburn over that over the past couple of years, and we've now gotten rid of that, and we've moved on to just having people tag features. So we're still looking for that general idea of finding those features that are limiting, but we're not asking people anymore to make a judgment call in the field on what is most limiting or just plain limiting or a typical limiting or anything of that sort. At this point, we want our data collectors out in the field to log any feature that they look at and go, okay, that's kind of interesting, that's kind of funky, let's log some data for that feature. And on the back end, we'll be able to take a look and see whether we feel that that particular feature is limiting based on our comparative approach. We've also updated the app to include more common channel feature terminology to provide more consistency. So there's just deeper data entry fields as you go through the application now. Okay, I talked about the color-coded fields. We also updated the app to allow for multiple photos. So if you've ever been out working in the field with the Survey 123 application in the past, the default setting is whenever you have a picture field, it just allows you to take one picture. You know, when you're trying to collect photos in a stream or in a complex system, you're going to be pretty darn lucky if one picture does a good job of cataloging what it is you're trying to capture with that photo. So we've updated the app, and you can actually take as many pictures as you want now of any individual feature. So we have different photo fields throughout the app. So if you go to what you want to call just a feature, if you've got some sort of nick point or, a log jam or something, you can take multiple pictures of that from different aspects to really try to capture the essence of what that is. And same idea with the interior of the culvert. So some of the lessons that we've started to learn as we've gone out there, one of our overarching goals within this program is to document best practices in AOP construction, document what works, what is working, and what could use some improvement. So one of the early ones we've been seeing is related to the inclusion of constructed banks interior of culverts. So not every AOP procedure requires constructed banks, but some of them do. And we've seen some performance questions, we'll say, with some of the different designs. There was a procedure out there for a while that required that those banks be built out of mobile bed material, mobile-sized materials to build a channel bank inside a culvert. And, as we go out and we're looking at these sites, what we're seeing is that mobile material was in fact mobile and moved. So fortunately for us, the contractors were so nice as to paint those orange lines on the side of the culvert that they were using as the guide themselves when they built the channel banks, but that must be documented as a best practice in construction for AOPs, because we've seen this at pretty much every single culvert that was built for aquatic organism passage. We see that. It's always orange too. I don't know how they settled on that, but we've got great evidence that we've come across in the field that the mobile banks are in fact moving, and we have other examples that went with more threshold size banks. So the photo from Georgia in the bottom left-hand corner there, that was more of a threshold bank design, and we've seen that those have held up very well. Some other observations we've seen, rock and log weirs. Sometimes we've seen those work great. We've seen other cases where if the bed material was moving downstream of those or other aspects of grade control were not holding up, that they started to become a potential barrier themselves. So, as far as our best practices go, I think we're putting that as okay, be careful when you're reliant on the weirs. One of the things that came from the biologists on our expert panel were, to have some concerns when you're talking about actual habitat inside the AOP, and if you're putting features in there that are really looking at fish habitat, that the other animals in the system have learned from that. So, Ted Castro Santos had a story about an AOP culvert that was this great brook trout stream, and they had these boulder clusters in there that the brook trout really liked going to, and then they had the snapping turtles that found those spots and actually now had a nice pinch point in the system for predation. So it was interesting lesson learned in the AOP design that habitat interior is not maybe always the best thing. In our procedure, we focus more on making sure that there is refuge, just some resting area for the fish as they move through the culvert, rather than emphasizing the need for habitat in the culvert. One consistent point of feedback we've been getting from the DOTs as we go out and deploy this procedure is how useful they see it being in bringing new thoughts as they're working on the design of culverts in their AOB program. So to kind of take a different approach to how we think about the design of the channel bed and the design of the AOP structure, they've all talked about how eye-opening it is for them in their ongoing designs, and that really supports what we're trying to do with this program and document those best practices and help improve future designs. Other ones, so discrepancies between what's designed and what's constructed. So this, again, why we have a stage 1 procedure, why we're doing our as-builts. We do find, sometimes we'll say, that what is documented on the as-built, maybe we don't have good as-builts. That's frequently an observation, is that we don't have great as-builts at a lot of these sites. We don't have good documentation on what that constructed bed exactly looked like, and we'll get out and do the stage 2 assessment. There will be a disconnect where this was not what we were expecting to find for various reasons. So it just emphasizes the need to have good as-built information to inform a monitoring program, and it's one of our points of emphasis moving forward. So the online database itself, I mentioned that we're pushing this all to a cloud-based online database. Right now, it's maintained through WSP's Esri ArcGIS online account. We are going to be working in 2023 towards migrating that over to USGS-supported database. At that point, the application and the database itself will become very open source. So anyone will be able to go in, any DOT that's interested and wants to have consultants or otherwise go out and continue to log their AOP systems with this process, will be able to do so as we migrate over to the USGS system. So next steps as we continue in this program and as funding is available, we've talked about putting together an interim success scoring system. So we've got a number of metrics already that we're looking at with the monitoring protocol, and we want to get some of that those initial scores on how a particular AOP is doing, how it's standing up, how it ranks compared to its peers in the area. So we're talking about that, I think, for 2023 as well. The USGS database launch, in the future evaluation and action plan. So this is more about getting that documentation out there on those best practices moving forward. And then we also have a hope at some point of working in biological data integration in there. We're not ever going to be able to go out and do full, fish studies and shock all these streams, that sort of thing. And it wouldn't necessarily be useful because we wouldn't have the preconditioned data as well. But we do know that there are a lot of agencies out there that already have that data. So we're hoping to get to a biological data integration step where we would be able to pull data from a state DNR or otherwise along these same systems and take a look at the success. So more immediately, we are doing a much more detailed live online training session on the protocol and on the mobile application we put together. So if you got a postcard today, it's the same QR code that's on here. It's scheduled for September 14th on GoToWebinar. So audience-wise, for this particular one, we've gone with a very broad target audience for this. So, everyone in this room, you're all very learned individuals. Maybe you're not going to need all the information that's going to come out of this training course, but we are doing some 101 on fluvial geomorphology, on AOP and otherwise. So if you have junior staff, I think that's going to be a great target is junior staff, maintenance staff with state DOTs, even down to interns and such that you think are good candidates to go out and collect AOP data within your own system. And with that, I'll thank you and open it up if anyone has any questions. Charlie.
Yeah, I know on one of the forums you collect basic design information.
Mm-hmm.
And are you actually collecting PDF files of plan sets and say the special provisions for the materials that are used?
So, well, in short, yes, that we have to do that to get the as-built data, but we've also put together an aspect of the database that's focused on the as-built data. So there is a Survey 123 form that can be used on a mobile app or actually on a desktop where you can go in and enter that, enter the as-built data. So we've got the different fields in there to catalog the as-built data.
I guess I was thinking is more DOTs have to start doing this if there was this collection of, of plans they could look at to get ideas for their own work.
I think that's a good idea, and I think that's something that Jim could talk to the USGS about as we figure out what this online database is going to look like. Okay, well, thank you.